Chapter number 6 now. Application of derivatives. So here we have different types of applications of derivatives. One application of integration you already studied as the area under the curve. Here we'll see we have different exercises. The first part is about rate of change of quantities. In this section we don't have any theory, but it is just about like dy by dx. You know what it represent. This represent rate of change of variable y with respect to x. We know this is precise meaning of derivative. Dy by dx represent what? Rate of change of one variable with respect to the other variable. That's the precise meaning of derivative. So with this reference we directly go to the first exercise here. It's just based on simple derivatives, you will see. So I'll write exercise here 6.1. the first question. Let's see what it says. Find the rate of change of the area of a circle with respect to its radius when you have r equals to 3 and r equals to 4. So first we need to write the relation about radius and area. So if r is radius, then area of the circle, you know, it is pi r square. Now you want the rate of change of area with respect to its radius. So you want dA by dr. Pi being constant as it is, derivative of r square with respect to r, it is 2r. So it is 2 pi r. Now there are two sub questions. The first question, if r is 3. So if r is 3 centimeter here, so change in the area with respect to radius, it would be here, put r equals to 3, so 6 pi. And you can write here a second sub question similarly. If r equals to 4 centimeter, then change in the area with respect to radius, so it will be 8 pi. So if you want, you can write the units also here, centimeter square per second. Here also area, so centimeter square per second, right? So as I told you, these are just simple derivatives. Let's see the second sub question here. Second question, volume of a cube is increasing at this much rate. So let's take V be the volume here. If this be the volume, then change in the volume with respect to time, dV by dt is 8 centimeter cube per second. Okay. How fast is the surface area? If I call the S as the surface area, then change in the surface area, increase or decrease, that is change. Surface area increases, so you want this ds by dt. When you want to get this? When the length of an edge is 12 centimeter. So if x equals to 12 centimeter, what is that x? That is the length of an edge. Okay, so we just try to correlate this and we differentiate. Okay, so let an edge of a cube equals to x centimeter. So if this is a cube, we consider length of each edge, that is x, this is x, and so on. So therefore, what is the volume? You know, volume is x cube, x into x into x, you know. Now we differentiate it. So dV by dt, we differentiate with respect to t because we have information about dV by dt. It is 3x square into dx by dt. You have used the chain rule. You must notice this. Right hand side you have expression about x square, x cube. So you have just used the chain rule. you know dv by dt. What is dv by dt? That is 8. 3x squared into dx by dt. We call this as equation 1. We keep inside. Now we want the rate of change of the surface area. So surface area, that is S. You know there are how many faces? 6 faces. 1, 2, 3, 4, 5 and 6. And each one is a square. What's the area of each of this? X squared. So total surface area is 6x squared. This is the formula. Now you want ds by dt. So differentiating s with respect to t. This is what you are asked. 6 into here 2x into dx by dt. Chain rule, differentiation with respect to t. Now you have information about dx by dt from 1. So this is 12x. What is dx by dt from 1? That is nothing but 8 by 3x squared. Here you can just write by 1. This is because of 1. So what we'll get from this? This is nothing but here 32 by x. Fine. But when you are asked this, when x is 12. So when x is 12, you have 32 by 12. So this will be just 8 by 3 area. So centimeter square per second. That's a required change in the surface area with respect to time. Let's see the next question, what it says. The next question says, the radius of a circle increasing uniformly at this much rate. The third question. So if r is a radius here, then you are given that, what's given? Change in the radius with respect to time. It would be 3 centimeter per second. Okay. Find the rate at which the area of the circle increasing, that is a change in the area. So you want dA by dt. This is a question. When the radius is r equals to 10 centimeter. It's just like first question. So we have the relation. You need to write the relation, that is area equals to pi r square. You want dA by dt. So differentiating with respect to t, dA by dt, pi constant as it is. What is this? 2r into dr by dt. 2r into dr by dt. Then what you need to do? You know this r also, you know 10. So pi into 2 into this is 10 given to you when r is 10. And what about dr by dt? It is just 3. So what will get? 60 pi centimeter square per second. That's the required rate of change. Write the relation and differentiate it. Fine. Next question. And age of a cube is increasing at this much rate. So let x be length of and age of the cube. Fine. So here we have the cube where measure of each side is x. This is x, this is x, and this one is also x, here also x. So what is given to you? Change in the age, that is dx by dt, is 3 centimeter per second. That is given to you. What you want? How fast the volume? So you want dv by dt. This is a question. When x is 10 centimeter. So just write the formula. We know what's the volume here. Volume V is x cube. So dv by dt equals to, here by chain rule, 3x square into dx by dt. You know everything here on the right hand side. What is x square? 10. So this will be 100. What is dx by dt? It's given to you 3. So this will be 900 centimeter cube per second. That's a change in the volume, or you can say increase in the volume. Next question. A stone is dropped into a quiet lake and waves moves in a circle. Acha. So there is a circle. So there is a change in what? Here one circle, second circle, and so on. There is a change in the radius. Right? Once stone is dropped into a water. So change in the radius. dr by dt. 5 centimeter per second. Okay, let me write where r is the radius. Fine. When the radius of the circular wave is 8 centimeter. Okay, so when r is 8, what's the question? How fast is the enclosed area increases? So this enclosed area, that's the area of the circle. So you want change in the area, that is dA by dt when r is 8. So now it's very simple for us. Write the relation for area of the circle, that is a equals to pi r square differentiated with respect to t. So dA by dt equals to pi into 2r into dr by dt. You have used the chain rule. You are differentiating with respect to t. Now right hand side everything is known to you. Pi as it is 2. What is r? 8. What is dr by dt? You are given 5 here. So finally you will get the required area, change in the area, that is nothing but here 80 pi, which is, you can write centimeter square per second. Increase in the area or change in the area with respect to time. 80 pi centimeter per second. Okay, 6th, I'll leave it for you. I'll go to 7th. The length x of a rectangle. So here x is the length of the rectangle. Length of rectangle. And y you are given, that is nothing but the width of the rectangle. Okay, now this is given to you. What is given? Rectangle, length of a rectangle decreasing at this much rate, that is change in the x with respect to time equals to 5. And the other one is increasing, so dy by dt with respect to time, which is how much? 4. Now this is increasing, this is decreasing, so just for this 2 I'll put the minus sign. This minus sign indicates that there is a decrease in this variable with respect to time, and this here plus sign indicates that there is an increase in this, right? So just to distinguish these two, we'll put the minus sign here. Okay, now the question is, there are 2 sub questions. The first sub question is find the rate of change of the parameter. So if I take p as a parameter, then the question is change in the parameter with respect to time when you are given x is 8 and y is 6. This is given to you. Now write the parameter formula. So parameter, you know sum of all the sides, that is twice x plus y. Now we just differentiate it. So dp by dt equals to, this is what you are asked, 2 as it is, derivative of x with respect to t, dx by dt plus dy by dt. You know both the values here. This is minus 5, this is plus 4. You are already given. So this will be just minus 2. dp by dt. So dp by dt is minus 2 centimeter per minute. Right? So what this indicates? Minus sign. So therefore you can write, if you want, perimeter is decreasing. Now you know this minus sign indicates here decreasing at this much rate, at a rate of 2 centimeter per minute. Fine, I've used the word decreasing, so now no need to put the minus sign here, but here this minus sign indicates there is a decrement in the parameter. Okay, what's the second sub question? That's the area of the rectangle. Okay, so here for the second sub question we need to write the area. So let A be the area here. So area, you know, it is x into y, length into breadth for a rectangle. Fine. This is y, this is x. Okay, so we want change in the area. So dA by dt. Now here your product of two variables. So we need to use which rule? Product rule. X as it is, dy by dt, plus now y as it is, dx by dt. Fine. I've used the product rule. Now we know everything. What is x? In both the sub questions, this is given to you 8. What is dy by dt? You know. What is dx by dt? You know. What is y? That is 6. Place here. So that's your required area, change in the area, sorry, which would be again centimeter square per minute. Just put the values and simplify. So in the next question, a balloon which always remains in spherical. Okay, so it talks about a sphere. So let's write here volume of the sphere, which you know 4 by 3 pi r cube, where r is the radius and here v is the volume of sphere. Okay, so we have this. Now is being inflated by pumping in 900 cubic centimeter of a gas per second. Okay, so it's a change in the volume. So we are given this, given that the change in the volume with respect to time, you just read the question, you will realize it is 900 cubic centimeter per second. So we have this. What is asked here? Find the rate at which the radius. Okay, so you want this change in the radius with respect to time, but when radius is what? R equals to 15 centimeter. So now what you will do, as you did in all earlier 7 questions, we have this formula. You just differentiate it with respect to t. So dv by dt equals to 4 by 3 as it is being constant, pi as it is being constant, derivative of r cube by chain rule. So 3r square into dr by dt. Now everything is known to you in this question. You know dv by dt 900. These all things are constant. R you know how much? 15. Place here. So you will get finally dr by dt by placing the values. And it would be your final answer in terms of centimeter per second. Just put the values and simplify. Next question, which is just like previous only. There the volume of a sphere, which is 4 by 3 pi r cube, as we know, where r is the radius of the sphere and v is the volume. Okay. Now here the question is find the rate at which its volume increasing, that is change in the volume with the radius. Okay, when the latter one is 10 centimeters. So we want the change in the volume with respect to radius when r is 10 centimeter. The previous question there it was with respect to time. Here it is with respect to radius. Okay, so we just differentiate this with respect to radius. So dv by dr equals to 4 by 3 pi being constant as it is. Derivative of r cube with respect to r, which is 3r square. So 3 will get cancelled. 4 pi. You want the change in the volume with respect to radius when r is 10. So here you just put 10, so this will be 100. So we'll get the 400 pi centimeter square. See the 10th question. There you are given that a ladder 5 meter long is placed along the wall and the ground. Okay, so suppose there is a ground here, there is a wall, there is a ladder here. This ladder is placed which is 5 meter long we call this as O here. I'll take the one end from ground to this wall as the X here. So what is X? X is nothing but what here? One end of ladder away from the wall, and this is nothing but the actually height on the wall where the other end touches. So I'll take the Y as, what do I take? The height at which your ladder touches. Fine, we have introduced these two variables X and Y. Let me call this as A, for example. This is B, so this is a triangle AOB, which is obviously right angle triangle. Fine, now what is given to you? You read the question, you can see it is given that the bottom of the ladder, that is this, is pulled along the ground. That means there is a change over here. That means there is a change in X. And therefore you are given that the change in X with respect to time is 2 centimeter per second. Okay. How fast its height? That is the change in Y you want. That's the question. So you want dy by dt. This is the question. When you want this, see the question. When the foot of the ladder, that is this, on the ground is 4 meters away from the wall. So when here X is 4, that's given to you. Fine. So we need to get the relation between X and Y. So here clearly in this triangle AOB, by, we know Pythagoras theorem, we have x square plus y square equals to 5 square, which is 25. Okay, so this is a relation. Here we have derived this relation from the diagram. In all earlier question, we had a standard formula. Now what we'll do? Obviously differentiating with respect to t. So here 2x into dx by dt, chain rule, 2y into dy by dt, 25 being constant, 0. We want dy by dt. 2 will get cancelled. So y into dy by dt equals to minus x into dx by dt. So we have dy by dt equals to minus x. The value of y from 1, you can put root of 25 minus x square into dx by dt. This is just from, from 1. From 1 you place the value of what? Y. Okay, now everything is known to you on the right hand side. X is 4. What about this? This will be 25 minus 4, 16. So this will be just 9. Dx by dt you are given 2. So you have minus 8 by 3. Fine. Now you know what this minus sign indicates? Yes, this minus sign indicates that there is a decrement in the height at which the one end touches. So there is a decrement in this. So I'll write here, if you want, just you can write here the height of ladder, you can write here height of the ladder on wall decreases at this much rate, decreases at 8 by 3 centimeter per second rate. So there is a decrement in the height. The other one was increment. Next question. A particle moves along this curve. Okay, so we are given the equation of the curve here, which is 6y equals to x cube plus 2. In short, an equation about two variables you are given. Find the points on the curve. So you want point on the curve, that is x comma y you want. This is the question. Find the points on the curve. That's the question. at which under this condition what's given to you? Given that y coordinate is changing, change in the y coordinate, that is dy by dt, change in the y coordinate 8 times as fast as the x coordinate, that is change in the x coordinate. This is given to us. Fine. This is given in the data. Now what we do? We just get the dy by dt from the above equation and we place here. Now by 1 let me write here 6 as it is. Dy by dt equals to 3x squared into dx by dt. By chain rule, derivative of y with respect to t, 3x squared dx by dt, and here 0. So here what we'll get from this? Dy by dt equals to, I'll take 6 down, so it would be half x squared dx by dt. But what is dy by dt? You know, it is nothing but 8 into dx by dt equals to half x squared dx by dt. Keep in your mind what you want. You want x comma y. So this will get cancelled. So we'll get the x squared equals to how much? You know, 16 here. And therefore, what is x? That's plus or minus 4. So now if x is 4, you can get the y very easily. From where you will get y? From the equation of the curve. So get the y from there. If x is minus 4, get the y from the curve again. Values of y you can get from the equation number 1. I'll just write here, you can write by 1. And therefore, you will get the required points here. 4 comma, values obtained from here. And the other value is minus 4 comma, the other value which you can find very easily. Right? So you were asked to get the points on the curve satisfying this condition. Change in the y coordinates equals to 8 times the change in the x coordinate. 12th question, radius of an air bubble is increasing at this much rate. So air bubble means it talks about what? Sphere here. So we need to write the volume of a sphere. V equals to 4 by 3 pi r cube, as we did number of times, where r is the radius and v is the volume. Okay, you are given the change in the radius. So what is given here? dr by, you know, dt you are given, that is how much? Half centimeter per second. This is given. What rate is the volume? Okay, so you want dv by dt. This is the question. Get this. When you want this? When r equals to 1 centimeter. So this is very simple. You have this relation v equals to 4 by 3 pi r cube. Differentiate it with respect to t. dv by dt equals to 4 by 3 pi into 3r squared, chain rule, dr by dt. Now you know everything on the right hand side. Just place the value and simplify. 3 will get cancelled. 4 pi as it is. What is r? Here it is 1. So 1. What is dr by dt? It is nothing but a half given to you. So what we'll get from this? 2 pi centimeter cube per second. That's the change in the volume, as we did earlier number of times. The 13th question, question number 13 here. Balloon which always remains in spherical shape. Okay, so again it's about a sphere where you are given here diameter. So we write the radius, which is nothing but the half of the given value, half 3 by 2 into 2x plus 1. You are given the diameter, so I wrote half here, so it becomes the radius. Find the rate of change of its volume with respect to x. So what we want? We want dv by dx. This is the question, right? Get the change in the volume with respect to x. Okay, that's what you want. Now, as means we know what's the volume? 4 by 3 pi r cube. We know this. So you just put the value of half from here. So v equals to here 4 by 3 pi r cube. So you have here 3 by 4 the whole cube into 2x plus 1 the whole cube. I repeat, 4 by 3 pi, 3 by 4. We are just placing these values. 3 by 4 the whole cube into 2x plus 1 the whole cube. Now what you want? This much is constant. You can simplify. You want dv by dx. So keep this constant as it is. Use the chain rule and simplify. So your final answer will be in form of x. Fine. Not difficult for us, at least now. Next question. That's also a good question. Sand is pouring from a pipe at this much rate. So there is a change in the sand. That means there is a change in the volume. The falling sand form a cone. Okay, so we have such a cone, like this. Here there is a cone. So sand is in this form. That's given to you. This is the base radius. This is the height of the cone. Fine. So let me take this as h here, height, base radius as r here. So you can write the volume here. So here volume V, that is, here 1 upon 3 pi r square h. We know this. Volume of a cone or just right circular cone. Fine. Now what is given in the question? Sand is pouring from a pipe at this much rate. So we are given change in the volume. So dv by dt, you are given change in the volume with respect to time, that is 12 centimeter cube per second. From the unit also you can realize that this is a change in the volume. Okay, this is given. And one more thing you are given, that the height of the cone, okay, that is h, is always 1/6 of the radius. That is 1 by 6 into r. This is also given to relation between h and r. So what we do here, we use this relation in the question number 1. What is asked in the question? Let's see that. How fast is the height of the sand? Okay, so you want the change in this. So dh by dt, this is a question. You want this. When the height is 4 centimeter. You want this when height, that is h, is 4 centimeter. Right? This is the question. We never put such value in the beginning, remember. At the end, this should be placed. Now what we want? We want height. We are given the volume. So we need to make this equation free from r. So we put the value of r here. So by 1, let me write here, volume equals to 1 upon 3 pi. I'm putting the value of r, which is nothing but how much? 6h whole square into h. I'll just write here r equals to 6h. Okay, so this would be just nothing but 36 by 3. So it will be 12 pi here h square, and this is h cube. Now we differentiate it with respect to t. So here we know dv by dt. 12 pi being constant as it is. What is this? 3h square into by chain rule dh by dt. You want this. Everything is known to you. What is dv by dt? dv by dt you are given, which is 12. So this is 12. This is 12 pi into 3 into, what is h? That's 4. So this will be 16 into dh by dt. So therefore, finally here, 12 will cancel. We have dh by dt equals to, this will go down, 48 pi. Right? This much is change in the height with respect to time, centimeter per second. Right? Change in the height with respect to time is 1 by 48 pi when h is 4 centimeter. The important one in that entire solution is this relation. And with the help of this, you have reduced this relation just form of volume and height. Why we reduce in this form? Because we want dh by dt, that's why. The next two questions are actually from commerce. You are given here in the question number 15, the cost function you are given. The cost function. It depends upon the number of units produced, which is x. So that is 0.007x cube minus 0.003x square plus 15x plus 4000. This is given to you. What is asked? Find the marginal cost. Now the marginal means change. So we are asked to find the change in the cost with respect to the number of units. That is dc by dx. This is what we are asked. When 7 units are produced. So here x is equal to, not 7, sorry, 17 units are produced. So x is 17 here. Marginal cost means what? Change in the cost with respect to the number of units. That's called the marginal cost. This is known as marginal cost, MC here. So we write therefore marginal cost, that is nothing but the change in the cost with respect to number of units. Okay, so we just get the derivative of this, nothing more than that. So we have here 0.007 into derivative of this with respect to x, which is 3x square, plus here we have minus 0.003 into derivative of x square, which is 2x, plus 15. Here you know it is 1, and 4000 being constant, it is just 0. Okay, now what we'll do, we are asked at 17, so you just need to put x equals to 17. So 0.007 into here 3 into 17 square minus 0.003 into here 34 plus 15, and simplify. This is your required marginal cost. I repeat, marginal cost means change in the cost with respect to the number of units. That much only. Now as far as the next question concerned, there in 16th number, what it asked, if you see, total revenue are given. There's revenue, cost, profit, loss, all these are terminology from actually economics or from the commerce. So here revenue are given. Revenue is the amount of money generated by selling certain number of commodities. So we are given this. This depends upon the number of units produced and sold by the company. That is X. X is the number of units. What is asked? Marginal revenue. That is change in the marginal revenue with respect to the number of units. When you want this, when X equals to 7. So let me write here, what is this? This is nothing but the dr by dx means what? Marginal revenue. That is a change in the revenue with respect to number of units. So what you have to do? You just differentiate this with respect to x, and at the end you put x equals to 7. So dr by dx, MR, marginal revenue, which is equals to 13 into 2x plus 26 into 1 here plus constant 0. So now at x equals to 7, you just place the value and simplify. So that's a required marginal revenue. Now last two MCQs, which are very elementary. Rate of change of the area of a circle. Okay, so A equals to pi r square. Change in the area of a circle with respect to its radius. So dA by dr equals to 2 pi r. But when you want this, when r equals to 6, so you put here r equals to 6, which will be 12 pi. So B. Question number 18 here. The total revenue, like the question number 16 here, total revenue received by sale of x units is given by this. So you are given revenue here, where x is the number of units. The marginal revenue, that is what you want, MR, that is nothing but the change in the revenue with respect to number of units. You want this. So 3 into 2x plus 36 plus 0 here. But you want when x is equals to 15 here. So just you put x equals to 15 here. So if I place just values there, you will get here finally how much? 6 plus 6 into here 15. So it would be here 90 plus 36. So it would be just 126. And that is nothing but your option D here. Fine.